Hello, everyone. Please welcome to session 7. My name's Alicia Webb. I work at a French renewable energy company called NEON, and I'm the Vice President here at Renew. I'm tuning in today from the land of the Wurundjeri people of the Kulin Nation, and I'd like to extend my respect to Wurundjeri elders past, present and emerging, as well as any First Nations people who may be joining us here today. Throughout the day, we've been sharing which Aboriginal lands we're joining from in the chat, and do please feel free to do so now. I'd like to thank Bryce Gayton and the participants in our last session. But before we dive in, I'd like to thank the sponsors who make today possible: the Department of Energy, Environment and Climate Change Action, NatHers, Your Home, Design for Place, Bank Australia, Sonnen, Hip versus Hype, Design Matters National, and Lighthouse Architecture and Science. For today's session, we're hoping to talk you through sustainable strategies to lower your energy bills amidst strong hikes in energy prices across Australia. Very topical, been in the papers even this weekend. Joining me is 3 excellent panelists and homeowners. First up, we've got Tim Forcey, founder of the hugely popular My Efficient Electric Home Facebook group, one that I personally peruse regularly. We've also got Paul Dolphin, director and principal designer of PDP Building Design, and owner of a great and functional family home that proves you can be sustainable while staying well below the average building cost. Check out the Sustainable House Day profile of his build through the link just shared in the chat. And finally, we're joined by Dylan Stone, owner of The Barn, a cosy straw bale passive house situated in the South Australian suburb of Warradale that's mastered energy efficient design. And again, we're sharing the link to Dylan's house profile in the chat. So don't forget, you can look through 130 house profiles this year and continue the conversation with homeowners in the comment section of each profile. So with no further ado, let's kick off. I've got a few questions to warm us up. I hope that's okay to my lovely panel. Tim, one of the great benefits of the My Efficient Electric Home is that homeowners and renters can discuss different ways of keeping their bills low and going greener. If I was new to the space and had no idea how to keep my energy bills down, what are the main areas where I should start, and where's most of my energy being spent?
Well, winter's coming and I'm here in Melbourne, Victoria. So 3 top items would be heat with your air conditioner, heat with your air conditioner, and heat with your air conditioner. So this has been the thing I've been banging on for 8 years. It's the reason that I started My Efficient Electric Home. 8 years ago at the University of Melbourne, even back then, we worked out that people could heat their homes with a reverse cycle air conditioner for 1/3 the cost of heating with gas. So this was like the best consumer win, reduce the cost of living, low-hanging fruit, all of that stuff. But 8 years later, I still walk into homes every day as a home energy consultant, and people still don't know that this is the cheapest way to heat your house. So that's a point.
A good one. I remember Alan Pears telling me that about 9 years ago, and I had a flat at the time and took out my gas wall heater and chucked in a splitty, and no regrets. Can I go to Paul with my next question? Paul, your home provides a great example of how using the correct materials can result in a sustainable home at no extra cost. Much of the conversation is about energy efficiency and energy efficient methods of heating and cooling, but where does design fit in supporting an energy efficient home, and how important are things like orientation?
Well, yes, I mean, I completely agree with Tim. We specify a lot of AC units where applicable, but I suppose the best dollar saved is the one that you don't have to spend in the first place. So yeah, if you orientate your building correctly and you look at really simple things, then it can have a huge impact. So our house is probably about 80-90% solar passive, and we do have an aircon unit for, you know, extreme temperatures, but a lot of it is down to good placement of windows, good placement of shading, good cross ventilation. And then, you know, once you've got those, they're actually all free, really. They just come with the price tag of a good designer, I suppose. But if you get your orientation and your windows and your cross ventilation working, then you can start to look at you know, things like double glazing, your type of insulation, your type of wall material, and then your space heating and your hot water heating.
Excellent intro. I've got a question for Dylan as well, just to kick us off. Dylan, your home, the barn, is another example of how simple design can reduce how much energy a house consumes. What have you done to minimise bills, and what would you recommend both for those starting new builds, but also those that are unable to buy a new property or retrofit their current home?
Yeah, I think it's already sort of been said, but orientation is pretty much everything. Well, if you're building new and if you're renovating, it's so important, and to the stage that we live in a climate that gets to 47 sometimes and gets to 0 in winter overnight. And because we've orientated right and then done the other things that Paul has spoken about with cross flow, windows in the right place, good insulation, and all those sorts of things, we don't even need an air conditioner or heater, and we stay at that sort of comfortable 22 to 25 degrees year round inside.
That's amazing.
Yeah, it's good.
So I am trying to find my next set of questions, and for some reason the link I have doesn't have any more questions, but I should probably not waste everyone's time and just ask another question myself. What is the most frequent question, Tim, that you get on My Efficient Electric Home, and why do you think it gets asked so frequently?
So I probably don't actually want to dwell on the most frequent one because it gets a lot of coverage, but that would be, what do you think of my quote for these solar panels? So obviously solar continues to be wildly popular, and with people hearing about rising electricity prices, and even people just switching houses, they'll go from one house to the other. Solar's been around a long time now, and so some people have had solar, but now they finally moved house to a different house, and so they want to do it again. But yeah, that would probably be the most popular thing. What do you think about this quote on the solar? Yeah, I'll just mention that.
I reckon I've seen at least 200 people saying, what do you think of my heat pump water heater install, and people commenting on pipe design.
Yeah, the hot water heat pump again is another one, because hot water is pretty critical, and it can come up in a real emergency that you need to replace that thing. So I certainly suggest to people, get your head around heat pump hot water. I mentioned you can heat your house for a third the cost with a reverse cycle air conditioner versus gas. The same technology, a heat pump, can be used to heat your water. So get your head around what a hot water heat pump is, and don't wait for your gas system to fail. I mean, if it's been out there a few years, it's probably time to move on, because again, you can heat your water for a third the cost with the hot water heat pump, and even less if you can manage to run your heat pump on a timer and use your own solar generated electricity. Then we're talking about maybe 1/10 the cost of gas. So we're talking about the cheapest hot water in the world, really. Get onto those hot water heat pumps, but don't wait to the last minute when your hot water system has failed, because it's very difficult to make a really considered decision when you're cold, wet, and naked.
Good point. I have successfully accessed my questions now. So I would like to ask all three panelists, what are your suggestions on how renters might convince their landlords to replace gas central heating?
Well, that's a tricky space, isn't it? Because there's that split incentive. I worked with a charity organisation a few years ago, and we were trying to create a model for landlords to be installing energy efficiency measures, and it's very difficult because there's a split incentive. There's no benefit to the landlord, is there? So yeah, it's a tricky one.
Yeah, it is. What do you think is the policy solution to that? Do you think we could push for the mandatory star ratings of rentals, or what do you think is the best way forward?
I'd agree with that, because that puts the pressure on the landlord, not the renter, who doesn't have any power in that situation, but is stuck in a terrible house quite often, and that which then forces them to have large bills and things like that.
Yeah, there should be minimums, but also mandatory disclosure, I would think.
Yeah, there is a thing that exists now across all the states. It's called the Residential Efficiency Scorecard. And it's not mandatory anywhere, but it was built because it could be mandatory. And maybe with the Victorian government, the same government having won the last election, maybe they'll start to bring it in for a class of rentals. That would be a hope. And so that's a policy ask. But this residential efficiency scorecard, it rates the building shells, very similar to the NatHers that probably a lot of people would be familiar with. And so that takes into account the orientation, the insulation, all that. But then it also adds in exactly what sort of system do you have there to heat the house, to heat the water, et cetera. Are there any solar panels on the place? And generates a star rating, again, 1 to 10, similar to NatHers, just to confuse everybody because it's a little bit different. But anyway, if that scorecard were required for rental properties, then a prospective tenant would be able to say, aha, that one rates 4 stars, this one rates 6. I can see why I should pay more rent for the 6-star. So that's a policy possibility. But getting back to your original question about gas central heating and rentals, et cetera, look, we should just be using air conditioners. And so you probably do find more reverse cycle air conditioners in rentals these days. So, but again, education is needed so that even renters understand that it's cheaper to use the air conditioner than gas heating, cheaper to use the air conditioner than electric heating. But I've been in homes where people just are making the wrong decisions because we've so thoroughly demonized the use of air conditioners. We're like, oh my God, an air conditioner is the devil. Only use it in case of emergency. Break the glass is the reason you would ever use a air conditioner. And so getting the message out to people that's actually the cheapest way to heat is important, even for renters. And maybe, I know that, maybe it should be that rentals do have cooling. That therefore brings in the air conditioner, make sure it's reverse cycle, and then voila, you've got the cheapest form of heating as well.
Yeah, good.
I just add.
Sorry.
Can I
please.
just add? When I was in the UK, there was a policy called the Decent Homes Programme, and it was based on 30 years of hospitalizations and accidents, and it basically identified 28 or 29 different hazards. And tenants could call it was basically a national scheme. All homes were supposed to be decent, and then the Tories got in, and it turns out most of them are landlords, so they kicked it out. But basically, 2 of the key ones there were excess heat and excess cold. And we were sent in as surveyors, and we would go around and we would identify, we would do the survey, and if it came back as a category A hazard, then the council could enforce the landlord, or would enforce the landlord to remove the category A hazard. It should be noted that, more people die from excess cold in their homes in Australia than they do in Sweden. And I remember when I first arrived here, I went to like a CSR product event, and they had interviewed expats from Europe, and every single expat had exactly the same statement. I have never been so cold in a house until I got to Australia. And I'd worked for 7 years in the Decent Homes Programme, landed in Australia in a rental property, and we had one tiny electric heater, and we could put the electric heater on or the kettle, but not both because the fuses would blow, and it's so yeah, a program like that would be very beneficial.
Yeah, that residential efficiency scorecard, in addition to the 1 to 10 stars, which relates to the cost of operating the heating, the cooling, the hot water, it also has 2 comfort ratings on a scale of 1 to 5. And most properties would probably rate just 1. But anyway, again, that could be a bit of a guide for a renter that, oh, this particular property for some reason actually gets 2 for the summer. That means that they'd be more comfortable there without having to turn the active heating or the active cooling on.
Yeah, it's a little bit embarrassing sometimes to hear those stories from Europeans, being an Australian, that our houses are like tents. The next question comes from Lenny, who says, I'm a renter. What are the easiest ways I can improve the efficiency of my home? It's always a universal question, that one. Yeah,
again, if the thing happens to have a reverse cycle air conditioner versus any other form of heating, that's going to be your cheapest option. But there are filters in there. And in fact, any sort of heating system or cooling system that blows air around, there's going to be filters in there, or there should be. So check it out and make sure that there are filters in there, but they'll probably be dirty. So clean them out, and that can be DIY. So that's one tip I'll throw to the other guys.
I'd say if you're somewhere that gets quite warm, if you can do some external shading, you can often get away with that cheaply and without doing anything permanent, even if it's just a bit of shade cloth to stop that sun from hitting the windows, or a nice big plant or a vine. Something like that's always good. If you're trying to get some more warmth, you're in a colder place, just clearing away, if you can, vegetation or things that are covering your windows to allow that sun into your house in those winter months for the passive heating and cooling.
Yeah, that's great. Great tip. Just need a pair of secateurs for that one.
Yeah. Draft exclusion. If you live in an old house with the vents up high, if you put something over that, that'll save you about 20% on your heat loss, because they were always placed high up in the first place. Yeah. So, and they were because of, I think, gas lighting maybe, or they wanted to get the air exchangers. So that's useful. And also LED light bulbs as well.
Yeah, that's a good one.
Can I mention the caveats about the wall vents? Yeah, here in Australia, they were there for the gas lights, but then also feeding fireplaces. And then we started burning a lot of gas in homes. And so this is the usual thing you say to clients, sure, get around to sealing up the wall vents, but first, make sure your gas heater's not trying to kill you with carbon monoxide, because then in that case, any air leakage might be the only thing that's saving you. So if you can't get off the gas heating, then you don't have to worry about the carbon monoxide. And so you could seal up those vents. But the other thing is moisture management, which is really important. And a lot of people, both renters and homeowners, are still, in the middle of winter with the windows closed, are hanging laundry around the house to dry.
I do that.
Yeah, so do not do that. In that situation, again, any air leakage, probably a good thing because it's going to take the moisture out of your house. But as we tighten up our houses and close air vents, etc., you got to really focus in on the moisture and cease hanging the laundry around the house to dry. It's not really that efficient of a thing, and compared to what else exists, and that is the heat pump condensing clothes dryer. So if you can get hold and afford one of those, a heat pump condensing clothes dryer is the way to dry the laundry in the middle of winter if you're not hanging it outdoors. Of course, hang it outdoors if you can, but in Melbourne, we find people can't do that usually every week of the year. So real caution there against hanging laundry around the house with the windows closed.
I'm very, very guilty of that, I must say. Shall we go to the next question? It's from Sam. What's the ongoing cost of running hydronic heating, and what PEX type tubing and size should this use? A very specific one there, Sam.
Hydronic, I guess the one thing I have to say about hydronic is in Victoria, of course, most of the hydronic is going to be burning gas. So it is possible to convert the hydronic to be using a heat pump as the energy source, sucking free renewable heat out of the air, just as a reverse cycle air conditioner or your hot water heat pump does. So it is possible to set up hydronic heating with a heat pump system, so you won't be using any gas. And I think I might have just lost my train of thought. Oh, well, there's but also there was an excellent article published in Renew. The author was Cameron Munro, and he wrote an article, Hydronic Heating versus Air Conditioner. And so Cameron tells the story of his home, which was open for Sustainable House Day a while ago, and I visited it on that day. And out the back, he had a wonderful extension, and it had a very good thermal envelope. It had heat pump hydronic heating under the floor, but it also had an air conditioner. And so what Cameron found is, with a decent thermal envelope, he didn't need the hydronic heating. He was able to just use his air conditioner in the Melbourne climate. The Melbourne climate changes quite rapidly, and one problem with hydronic can be that it's quite unresponsive, particularly if you have a decent thermal envelope. So the message is, get a decent thermal envelope, either if that's new or retrofit, and then you'll find you don't need the hydronic heating. So there, I just saved you $40,000, but you will have a reverse cycle air conditioner and run that from time to time. And that's what Cameron found, and he was happy to write an article about how he'd thrown away $40,000.
Thank you. I appreciate saving 40 grand. Always incredibly handy.
I'll back that up as well. I see a lot of people putting in underfloor heating, even in South Australia, and it's just, if you're building a new home, it just seems absolutely nuts, because if you have a window in the right place and even an exposed like concrete floor or something like that, you wouldn't be able to use it even if you put it in, and then you've lost your $40,000. You could have put on a nice car or some nice windows or better garden setup or something.
Fascinating. I've got a couple more about gas. One is from Genevieve. Is it always worth upgrading your gas heater? I mean, maybe Tim, just to be more specific, are there circumstances in which it's not? And how does gas compare to induction cooking in terms of prices? Well, it's so volatile out there at the moment, but let's just try and answer for now.
So was the first question, should you ditch the gas and get heat pump reverse cycle heating happening?
I think we know that your answer will be yes, but the question is it always worth doing? Is there circumstances in which it's not worth doing?
Why would you like to pay 3 times as much for heating? Here's a story. I had a client the other day, a young couple in their house, and mid last winter, their ducted heating died. But fortunately, they had a reverse cycle there, so they could stay warm for 3 weeks while they had their ducted heating replaced. And then they went back to using the ducted heating because no one had ever told them that the cheapest way to heat was the reverse cycle. So here I'm sitting in this house, and I'm saying, use that, and the thousands you just spent to fix your ducted gas heating, sorry, that's in the past. Maybe you can take it out and sell it or something, but there'd be no reason to be using a heat source that costs you 3 times as much. And also, of course, has all the damaging environmental and societal impacts. Down here in Melbourne, Victoria, we used to have cheap gas. Those days are gone. I could go into a long story about, the end of the Bass Strait gas supplies where I used to work, but I've already written that up in Renew magazine. So just search my name and goodbye to Bass Strait gas, and you'll see why it's a really good opportunity to be getting off gas through Victoria, New South Wales, South Australia.
Yeah, getting off gas is a pretty huge topic. Any other comments, Dylan or Paul?
I always forget that people still use gas. People deliberately put gas into new houses, or my neighbour the other day dug up the street and put gas into an old house. So it's easy to forget, especially if you're in this space, that you're used to having an all-electric home. But if there's anyone out there who isn't sure about disconnecting from gas or not using gas, I don't know any reason why you wouldn't do it. And once you experience whether it's induction cooking or you have electric hot storage for your water, it's I'd say it's better in every way. And then if we're talking about efficiency and cost, you'll never have a gas bill. So, and you also then don't have gas in your house and all the health impacts of that. But if a couple of the major hurdles, perhaps in Victoria, it's more to do with heating. But as Tim's talked about, air conditioning can power through that, especially if you seal your house well. But a lot of people are scared of induction cooking just because it's different. I didn't like it as much at first. Now I could never go back to gas. And I think a lot of people have been burnt by bad water heaters in the past, storage water heaters that run out of water, and then I've got a cold shower. That's not really the case if you size your system correctly. So if you're getting a heat pump hot water system, you just size it to the size you need, and also it can run more often, unlike in the olden days when it would only run at night on the off peak and things like that. So problems of the past that were perhaps drivers for people to get gas just don't exist. So if anyone out there is thinking, oh, could I do it? It's absolute no-brainer. So I'd say 100% on all fronts, get rid of anything you've got for gas, and then you've got one less bill as well.
I'd agree with that. And I'd say where we are in a sort of semi-rural location, you've got to pay to get it delivered. It's hard work. And then when we were in Malua Bay, through the bushfire, you could hear them going pop. So it's definitely safer if you don't have explosives strapped to the outside of your house.
Yeah, back to the cooking thing. If you do succeed in getting off the gas for the heating and you get off the gas for the hot water, then you're just left to the cooking. And cooking doesn't use a lot of energy either way. But if you're still on gas, you'll find you still get a pretty big gas bill for just about that much gas. And why is it so big? Well, it's because you're still paying to be connected to the gas grid. And in certain places, that might be $300 a year or more. And so you're looking at paying that for the rest of your life unless you get off gas. So you get off gas and then ring up and say, stop sending me the gas bill. And you can also ring up and say, take the gas meter away. I believe before you were talking about LPG gas bottles, but for people on the gas grid, still, why would you like to have the meter hanging around your property with hazardous material in it? So get that removed as well.
Yeah, these are all definitely important ones to have on the to-do list. Mike did ask just the prices of gas cooking versus induction cooking at the moment. Do you think that the mathematics, I mean, we've already talked about emissions and safety and air quality, but do you think the mathematics of prices are changing in the current climate of hiking electricity prices?
Cooking doesn't use a lot of energy either way, so we're talking about fairly small cost impacts there. I guess for some people who are on gas, but you know, there are barriers to getting the induction cooktop. I'd say try a portable induction cooktop. So for like $50, you can get a portable induction cooktop. $100, you might actually get a 2-burner. And if you go at the Facebook group, My Efficient Electric Home, type in portable induction, you'll see what all our various members have done there fairly creatively. But yeah, for $50, you can get an induction cooktop, plug it into the wall, no electrician needed, and you're on to induction cooking straight away. So that can be a fairly economical way to at least try it.
Good tip. A gentleman called Jens has just put in the chat that IKEA sells a portable induction cooktop for $70. So it sounds like a reasonably straightforward experiment to try if you were tempted. I've got another renting question, but this one's from Kathy, who's a landlord. She rents out an old 1970s style unit that has a gas heater. And she says, should she replace it with a split system or an infrared heat panel or something else?
Yeah, my vote would be the reverse cycle, because probably everywhere in Australia, you're probably going to want cooling from time to time. So provide the tenant with that. But then, yeah, your reverse cycle is your cheapest way to heat. Like I said, gas is 3 times more expensive, but a far infrared panel might be 5 times as expensive way to deliver heat as reverse cycle. Yeah, the far infrared, I've not really found a place where there is a good application for those. Someone might have come up with one. Again, it can be almost like the underfloor heating that was discussed before. By the time you turn the thing on, it's actually doing something for you. You probably left the room anyway. But it's an expensive form of heat for sure. It's not a heat pump. It doesn't get free heat from outside of the house. So just have that in mind.
I've had an interesting question from Susie, and given that there are over 600 people on this call, it might be a helpful one. Who wants to have a go at explaining what a heat pump is? Yeah,
I've done a couple of webinars that you'll find at the Renew YouTube channel. So Renew's got a YouTube channel. It's excellent. And I had the good fortune, was invited by one of the members to do one on hot water a while ago. That was at Melbourne Uni, so we just recorded it, but it's there. So search my name, Tim Forcey, Heat Pumps Part 1. That's about hot water. And then we decided it'd be a good idea if I did another one on heating and cooling. So Heat Pumps Part 2, heating and cooling. Look here, let me give you the story. It's hogging the scene here a little bit, but what the heck? You did ask. Say you're halfway up a hill and you got a bucket of water. If you tip the bucket out, the water flows which way? It flows downhill naturally, but it is possible to get water to go up the hill, but you got to buy a water pump. Well, heat, like water, is a thing. So if you had a bucket of heat in your house, where would that heat want to go? It wants to go from a hot place to a cold place. So the heat wants to go into your refrigerator. So they invented the heat pump or the refrigerant system as a way to capture heat and move it in the direction opposite to the flow it would like to go naturally. So in your fridge, you have the 5 key components of the heat pump or refrigerant circuit. You've got the refrigerant fluid to begin with, but when it goes through an expansion valve, it gets really cold. It goes through a heat exchanger where it can collect the heat away from your food. Then it goes through a compressor, which warms up the refrigerant hot enough. So then it goes through another heat exchanger wrapped around your fridge. And so that heat can be rejected back into your kitchen. So with that sort of magic, we were able to get heat flow in the direction opposite as it would naturally. And so then basically the same technology was used to cool an entire house. We called that air conditioning. Then they said, aha, we can run that reverse cycle and we can actually capture heat from outside. I mean, even if it's 0 degrees outside with a properly designed heat pump where the refrigerant might be like -25. It will absorb free renewable heat from the environment. The refrigerant gets warmed up, goes through a compressor. Now it's hot enough to come into your house and heat your house. So that's heat pumps for heating houses and heat pumps for heating water. There you go.
Thanks, Tim.
I think the thing to add to that a lot of people, when I'm explaining it, is that if you turn a kettle on, you are using electricity to heat water. If you use a gas flame, using gas to heat a pan of water. The difference with the heat pump is you're using the electricity to run the pump and the refrigerant to move heat from one place to another. And that's the crucial difference, because if you use electricity to heat hot water, you can only ever get a maximum of 1 unit of hot water for 1 unit of electricity. And the same with gas. If you burn 1 unit of gas, you can only ever get 1 unit of heat. But with a heat pump, because you're using the heat pump to move heat from one place to another, the electricity is not generating the heat, it is moving heat. Then you have a thing called a coefficient of performance, where you can get more than 100% heat. So you can get, Tim will be able to tell me the better figures, but up to coefficient of say 6 or a coefficient of 3. So for every 1 unit of electricity, you're now getting 3, 4, 5, 6 units of hot water. And that's the crucial difference. Even if you don't understand refrigerants, you're using the electricity to move heat from outside into your hot water system, or from outside into your front room, or the other way in terms of a fridge, or you're taking heat out on a hot day. That's the difference. So you can only, it doesn't matter how efficient your kettle is, or your standalone hot water, your immersion hot water system, or your gas instantaneous, which has, the gas combi gas boilers we used to put in England had, 97% efficient, but that's never going to be as good as 600% efficient. So that's the crucial thing for people, and that's where it suddenly becomes so much more cost effective.
I hadn't thought of that, but that is really compelling.
Renew is a non-profit membership organisation. Along with running Sustainable House Day, we also inform government policy, advocate for a fair energy transition, provide resources for climate disaster resilience, and publish 2 magazines. Sanctuary Magazine provides trusted independent information for people looking to build or renovate sustainably. Renew Magazine is a leading voice on sustainable technology developments shaping the energy transition. These magazines grew from member newsletters in the 1980s and still maintain their grassroots independence and practical approach. Both are incredible resources, and subscribing is a great way to support us to transform Australian homes for climate and energy resilience.
We've got a good one now that I think moves away from appliances and back to building design. Shane has asked, what's the difference between Scorecard and NatHers for a renovation, not a new build? And can you just list some of the pros and cons of the two so he can, select one for his reno?
I think if you're doing a reno and you're required to do a rating, then I think it has to be NatHers. And that, as I said, will focus just on the building shell, although they are coming out with NatHers whole of house. And I guess NatHers looked at Scorecard and got a bit jealous that it didn't have the appliances in it like Scorecard did. And so now we're going to see NatHers whole of house, which will have the appliances in it. But I think in the case, if you're doing a significant renovation where you need to have a rating done, legally, then I think it's going to be the NatHers. Scorecard could give you some additional information, once you've decided, what are the appliances you're going to use to heat that, that floor space there in the renovation. And then as NatHers whole of house comes along, well, the two things are kind of merging, I guess, but yeah, that might be beyond my expertise.
Dylan, Paul, do you have comments on NatHers v Scorecard?
I'm going to be honest with you. I've not heard of the residential scorecard until Tim mentioned it. So I don't know. So,
Yeah. So check it out. It's an interesting little tool, and a fundamental difference is NatHers is a thing that's often done, with the plans, and you can do that with Scorecard too. But really, where Scorecard was kind of designed was for existing buildings. Like I said, maybe it becomes mandatory for a rental. So an assessor walks into the rental. You measure every room, measure every window. Which way is it facing? Are there awnings? Are there eaves? Fairly quickly, surprisingly, you put like 500 pieces of information into the computer and push a button, and that's where you get the scorecard rating. So it's a thing you do on site. I mean, if you've got some documentation about the build, well, then that helps and helps to further legitimize the whole process. A scorecard assessor has to take a lot of photographs and upload them to the government database so it can all be audited, et cetera. So they've put a lot of work into it over the last 10 years of development. To make sure that it's not something that's going to be rorted and can be legitimate. But after 10 years, it's still not mandatory for anything, so it doesn't get a lot of use or a lot of publicity.
Yeah, I think with NatHers as well, like you've got to always bear in mind a lot of those programs are only as good as the parameters that have been set, and they always have to make assumptions, so it's like when you look at programs that, for example, model, the carbon footprint, there's always so many assumptions in there, and I've found it very interesting in my role as a building designer how so our house, for example, that we designed scored really low on BASIX because BASIX didn't take into account our thermal mass walls, internal walls and things like that. It didn't take into account certain things that we'd done, and it's amazing that sometimes you see what we would consider inefficient houses scoring well on NatHers and BASIX, and good energy efficient houses not scoring as well because it's only what it's looking at, So I think those tools are really good, but and even the intention of BASIX, was to basically force. A lot of legislation is to force the laggards, to force, the project home builders, or force people to put their seatbelts on and do those things. And so really, if you want to really have an energy efficient home, you need to be talking to experts like a good designer or a good architect or a good energy efficient advisor in your local area who's going to know your climate, and really take some of that modeling with a little bit of a pinch of salt, I suppose.
I'd jump in and agree with you there in that there's so many of those things out there, but to use someone who's specifically designing your house or your extension to be energy efficient and a comfortable place to be in is going to put you already in a good place. So it'll be less important which one of those things they use if you apply all those principles for the project.
Yeah, and there's like one of the first things, or one of the key things I always ask my clients is, which bothers you more, being too hot or being too cold, and everyone's perception of being too hot and too cold is very different, so it's challenging, and it should be a personal thing. If you're designing a house or a renovation or an extension for yourselves, it should be tailored to you. I mean, we should have, as Dylan mentioned before, there are parameters, 18 to 22 or 18 to 25 or whatever it is as a comfortable, but then, each person's perception of heat and cool is very different. And standard modeling doesn't take that into account,
Yeah, one little story with the scorecard. Once when we were just doing some early beta testing, I modeled a friend's house and it came up with a poor score and said it was quite uncomfortable. And my friend said, it's very comfortable. I live in one half in the winter and I live in the other half in the summertime. Whereas the modeling will assume, normal behaviors rather than, as you say, something specific to the individual.
Yes, we overglazed our Western sitting room. So we have a little, TV sitting room. We actually purposely overglazed the west of that, and we have external shading. We take that external shading down, and that room is so nice and cozy in winter. It can be 22, 24 degrees, on a winter's day when it might be, you know, -2 outside. But again, with the traditional basics, even with the shading, it penalizes you on it, you know, and the NatHers penalizes on it, but it works incredibly well for us.
Those are great insights. Thank you. Just on the topic of NatHers and Scorecard, Kit has asked if they take into account life cycle assessment.
Scorecard doesn't.
I don't think NatHers does. No, I don't think
All
so.
right, Kit, a really brief and clear answer to your question there. A couple about electricity, which I think is pretty interesting, given how much we've been talking about getting off gas. Kate lives in a townhouse complex and has been told she can't install an induction cooktop because of the amount of power it will draw, which will affect power available to neighbours. Has anyone come across this before?
I suppose it's possible. I guess I'd say, you know, the more electricians you could have look at the problem, maybe someone will come up with a solution. But one way around it could be the portable induction cooktop, which you don't even need an electrician to plug into the wall. Yeah.
Yeah, that would be a good workaround, wouldn't it? I would be also, I would be, if it depends, if that building's quite old and they're saying that, I would be asking when was the last time the wiring was upgraded? Because that sounds a bit scary.
And what's the plan at the accommodation to, you know, to move off gas? Because we're all going to be doing that someday, and also charging the electric cars. So what's the plan there?
Good point.
It could also be affected by the supply to the individual units too. So if they've got only a certain level of supply, and if you're then putting in a large induction cooktop, it might be too big. So they could look at what size they get as well. So if they've only got a 600 mil cooktop, maybe that's going to be okay. Whereas if you went to a bigger one, it needs to allow a high amp rating. And if that's too large for the individual units, given the supply that they have, then that could also be a workaround.
Yeah, I know, like in a freestanding home, yeah, if you buy an induction cooktop, it's going to have a maximum possible power draw if you assume that you turn all the burners on full power. Of course, no one would operate that way for long. And as I said, cooking doesn't use much energy. But yeah, if you turned on all the burners of an induction, that's a lot of power. But sometimes I know in a freestanding home, you can work with your electrician to say, if she is run into some limit, that you can say, well, look, I never will turn all the burners on full power. If I do, of course, I know it'll flip the switch, and I'm smart enough to go reset that and not do that again. So sometimes there is some flexibility working with an electrician.
Cool. And on the topic of electrification, a question that I think is quite interesting. What thoughts do you three have on resilience, given that whilst our electrical grid is very reliable, internationally reliable, there are areas in Australia that experience outages here and there. So what advice would you give people who are fully electric and experience an electricity outage?
So if I can speak to that. So we went through the 2019-2020 bushfires, and it burnt to our front door, and we had intermittent power for about 6 to 8 weeks. There was hardly any power in the local area, and we have a 6 kilowatt solar system and a 7 kilowatt battery, and we specified an EPS, emergency power supply. So amazingly, they don't come as standard, but if you are looking at a battery, we specified one of those, and then we specified which appliances it would go to. So it goes to our fridge, and it goes to our lights, and it goes to one ring of sockets in the kitchen. Everything else goes off. So our hot water went off and our cooker goes off, but the fridge, the lights, and our mobile phones and everything. And so we were while everyone else was, you know, while profiteers were coming down from Sydney with truckloads of knockoff generators, and people were paying over the odds for them. People were paying $3,000 for a generator they were never going to use again, you know, whereas we paid $6,000 for a battery, which saves us money every day. And, you know, when the power goes off, it just instantly kicks in. And so for those 6 to 8 weeks, we had cold beers and cold milk, which is pretty much all you need.
Great tip. Any other thoughts, Tim or Dylan?
Yeah, some folks think about resilience to do as a reason to do nothing. They'll say, oh, look, I'll just keep the gas heating, the gas hot water, because that's more resilient should we have a power failure. But then you point out to people, did you know that your ducted gas heating actually uses a lot of electricity to blow air around? And or your hydronic needs an electric pump. And also your tankless instantaneous hot water system also uses electricity. So yeah, have a look at your gas appliances before you think they're going to perform if there's no electricity.
Yeah, and interestingly, we've got a heat pump hot water system, and that was superheated, and the hot water in that lasted so long. It would last between each outage. So we would have power for a day or two, and then it would go off for a week, say, and in that time it would charge up, and then it would last for a long time. Whereas, yeah, Tim's right. Everyone who's on the gas instantaneous, the pilot lights out, they're all coming around to our house.
You'll have to share your address in the comments.
If you have a similar setup to what it sounds like Paul has, and you have a battery and you have storage hot water, and you've had your storage hot water set to be running the day, and your battery's keeping the power on thanks to the solar, your solar is going to charge your battery in the day. So you effectively will become off grid, and then when the power's on, you're back on the grid, but it doesn't matter. So you can run your whole house off of that as well. So Paul's setup is a few circuits, but depending on your house and your load, you can have the battery running across the whole of the house. So then, yeah, you don't have to worry about hot water or anything if you're an all-electric house, whereas you'll never be able to get that to happen with gas. And there is also, people don't think about, because the power goes out, it's quite obvious. Sometimes gas goes out. There was a big explosion years ago in Melbourne, I think, and gas went out for months and months. So there are, it's not just, gas isn't like super crazy, amazing, bulletproof system either. So another cross off the list, I think, for gas.
And I should probably mention something that was in the news very much in Melbourne this week. This winter, if we have a week of cold weather, the people that operate the gas system aren't really sure that there's going to be adequate gas supplies if a bunch of unlikely events occur. So there you go. So much for resilience with the gas network.
Can I just add one thing to?
Please.
So someone's just said batteries usually cannot run the whole house. Yet we actually, the day that we evacuated and we came back, the batteries had actually drained down completely, and they would shut off. And we needed to, I don't know what, we tried to work out, we tried to talk to the solar installer and the company. We don't know why, but when they ran out of battery, they would need to grid connect to start recharging again. And that was the first day when we were away. Well, we actually then made sure we had to sort of keep our eye on how much was in there. So, we were kind of balancing it. So we couldn't run an induction cooktop or anything like that. So we were actually out cooking on the barbie that, but we managed to maintain enough power to keep the fridge running and that sort of stuff.
Essentials. We've only got a few minutes left, but I thought Lisa had a good question that might just be one of general interest for some of the 600 odd people on the call. If you can't afford to do all your insulation at once, where would you start? Ceiling, walls, floor, somewhere else? Where would you start?
Depends on your house, I guess.
Yeah, it depends on your house. And you've got to remember as well, like insulation only gives you a certain amount of payback. So if your first 5 inches gives you 95%, then your second 5 inches only gives you 95% at 5%. So there's quite quickly a limit to the amount of payback you're ever going to get from it. I think we've had a lot of success with underfloor insulation where houses are raised up off the ground, because those spaces are only ever giving out heat really. And I think that people actually interact with the floor quite a lot, so people really seem to feel that benefit. I think dealing with your fenestration is actually really important as well. So windows, if you have single glazed windows, when we feel colder when we have air moving over us. So you can be in a different temperature but feel warmer because the air is stationary. That's the power. You know, you put a fan on, doesn't make the air any colder, it's moving the air over you. So reducing drafts and reducing air movement, and single glazed windows create convection within the building. So if you sit under a single glazed window, you will feel much colder. So one of my advices would be, you know, reduce drafts, reduce air movement within the building. So even, you know, heavy drapes or heavy curtains, that sort of stuff, if you can't afford to replace the single glazing, but that would be a good start.
Awesome.
The insulate, you know, the floor, the walls, the roof, all of that eventually. I mean, that's been the minimum building standard for a long time in Australia. It's not like it's some recent hippie greeny thing. So the question is, yeah, with your finances, how long would it take you to get there, to bring a house up more to a modern standard? But the lowest hanging fruit, and this is a really important one, is, yeah, if safe to do so, look up in your roof space, and you might find you have insulation, but it's scattered all around, because any trade that goes up there tends to move the insulation and not put it back. So it can be a relatively easy DIY for some just to put the insulation back. And if you have good insulation, but you know it's got a bunch of holes through it, well, there's a curve that drops off very quickly again. And so you've really destroyed your roof space insulation by shifting a fair bit of it around. And likewise, you know, the whole downlight legacy means we've got like a Swiss cheese of insulation up in the roof space. So getting the insulation into a consistent, perfect layer where there's no bare plaster exposed is really important. Sometimes not that hard to do.
Thanks, Tim. Any closing comments on that, Dylan?
I've done a house ceiling before, so and that like that day we could feel the difference. So I don't know, that's in a previous life before having my current house, but living in a house that had no insulation, got up there, all the stuff that was flat after years of compression and dust, took that out, and like Tim said, made sure it was all well joined, no holes above lights or things like that where you can, and we could feel it instantly. Yeah, big difference getting it in the ceiling.
Insulation
Amazing.
works.
Yeah.
Who would have thought?
No doubt. We actually have to wrap up, but I really want to thank our wonderful panelists, Tim, Dylan, and Paul, for a really great chat. Thank you for your time on a Sunday afternoon and for sharing your wisdom with all of us. I learned a lot, so thank you. Don't forget, everybody, that the Sustainable House Day program doesn't end today. We've got an entire month of extension sessions that offer a deeper dive into 8 key areas of sustainable design. And a pass for all of those sessions comes in at $60, which is pretty amazing value at just $7.50 for each 2-hour in-depth expert session. It all kicks off on Tuesday, so grab your pass via the link in the chat. Stay with us now for the last session of the day, all about sustainable design on a budget, which kicks off at 5 p.m, so in 5 minutes. And lastly, just a reminder that becoming a member of Renew throughout Sustainable House Day will put you in the draw for an electric scooter from Benzina, valued at $5,000. And you'll also support Renew to host great events like this. Thank you, everyone, and have a lovely afternoon.